Hello everybody, welcome into another lesson. So today we are going to talk about permutations and combinations. Now, permutations are where the order of a certain arrangement of items or numbers does matter. Combinations, on the other hand, is where the order does not matter. So let's first start with permutations. So again, the order of an arrangement does matter. So let's say, for example, I have the numbers 1, 2, and 3. Well, if the order matters, if I want to arrange all three numbers, those could be arranged as 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, or 3, 2, 1. Those are the possible orders for these numbers, if the order does matter. It's kind of like if you're playing the lottery. Usually, when you play the lottery, you have to get the numbers in the exact order to win the top prize. Now, I know some certain drawings, certain types of lottery games could be combination based, in the fact where if the order doesn't matter, you could still win a prize, but you may not win the top prize if it's not in the right order, or it could be some where the order doesn't matter. But usually, I know here in the United States, like your Powerballs, your Mega Millions, you have to hit the numbers in the exact order. So that's based on permutations. Now, in general, for permutations, that capital P of this NPR, this means you're taking n things r at a time. The formula for that is given as n factorial over n minus r factorial. So just as I did this example with the numbers 1, 2, 3, I'm taking three numbers 3 at a time. So that would be my n of 3 factorial all over my 3 minus 3 factorial, which gives me 3 times 2 times 1 over 0 factorial, which is 6 divided by 1, or 6. So there are 6 possible permutations, or 6 possible orders for the number 1, 2, 3 in this particular case. So let's do some examples of permutations. So let's see here. I'm going to take... That's not what I wanted. Yes, let's say I'm going to take 8 things 3 at a time. So I'm taking the permutation of 8 things 3 at a time, whether that's numbers, whether that's an order of items, or what have you. So that 8 is my n, so I'm going to take this 8 factorial divided by that 8 minus 3 factorial. Well, that's going to simplify that into 8 factorial divided by 5 factorial. So if we remember from earlier in the unit, when we started sequences and series, how we deal with simplifying factorial fractions. In the numerator, this could turn into 8 times 7 times 6 times 5 factorial divided by that 5 factorial. Well, your 5 factorials will cancel out. You'll be left with 8 times 7 times 6, which now we just turn this into a simple multiplication problem. Let's go ahead and do the multiplication. So let's see. We're looking for 8 times 7 times 6. That would give you 336 possible permutations. So you'll have 336 possible permutations for 8 items 3 at a time. Let's do a couple more permutations, then we'll move on to combinations. Alright, let's say I'm doing the permutation of 20 items 2 at a time. So I'm going to take 20 things 2 at a time. Alright, so this is going to be equal to, that 20 is my n, so 20 factorial all over my n minus r factorial, so that'd be over 20 minus 2 factorial, which would simplify into 20 factorial over 18 factorial. And we can simplify the factorial in the numerator. This would be the same thing as 20 times 19 times 18 factorial all over my 18 factorial. Well, the 18 factorials will cancel out. We'll just be left with 20 times 19, which should give me 380. So if I take 20 things 2 at a time, there are 380 possible permutations. And you know, I just thought of something. What's the deal with combination locks, right? Because if you really think about it, don't you have to enter the proper order of the numbers in order to unlock the lock? Shouldn't it really be called a permutation lock? Now granted, maybe when the factory's setting the combination, or if you change the combination, you can choose any combination you want where the initial order doesn't matter, but if you were to keep using that lock and you want to open it, you have to put in the proper order. So really, I would think a permutation lock would make more sense, but hey, I don't make locks, but I digress. So last one of permutations, let's take 7 items 4 at a time. So 7 things 4 at a time, well that then is going to be 7 factorial all over my quantity of 7 minus 4 factorial, which would simplify into 7 factorial all over 3 factorial, which would simplify further into 7 times 6 times 5 times 4 times 3 factorial all over 3 factorial. Well, the 3 factorials cancel out, so you have 7 times 6 times 5 times 4. So that should be 20 times 42 should be 840. So that means if I take 7 things 4 at a time, there are 840 possible permutations where the order does matter. Alright, so that's it for permutations. Let's get into combinations. So now we are going to talk about combinations. And as I stated earlier, the order does not matter. When you're dealing with combinations, the order of the items does not matter, whether it's numbers or anything else. So you're going to have a very similar formula to permutations, but instead of a P, it's a C, which means combination, for the combination of n things r at a time, so that NCR. That formula is given by your n factorial all over r factorial times n minus r factorial, which is actually going to be smaller numbers. You're going to see why in a second. Let's say I take that same number set 1, 2, and 3. I have the 3 numbers 1, 2, and 3. Well, if the order doesn't matter, and if I'm going to take all 3 numbers at once, I could put them in any order. So let's just do the basic 1, 2, 3. That just leaves one combination, right? Because they could be in any order. There's your combination of numbers. That's all it is. So for this particular example, I'm taking the combination of those three numbers, all three at a time. So that's going to equal my 3 factorial divided by my 3 factorial times 3 minus 3 factorial. Well, your 3 factorials are gone. That's just going to be 1 over 0 factorial, which equals 1 over 1, which is just 1. So in this case, there's just one possible combination. Now, if we were taking the order, you would have 6 possible permutations, but there's only one possible combination. So let's do some examples of combinations. So let's take the combination of 5 items 2 at a time. So we're going to take the combination of 5 items 2 at a time. So this is going to equal my 5 factorial all over my 2 factorial times the quantity of my 5 minus 2 factorial. Well, this would simplify into 5 factorial all over 2 factorial times 3 factorial, which could simplify further into 5 times 4 times 3 factorial all over 2 factorial times 3 factorial. Now notice my 3 factorials will cancel out. 2 factorial is simply 2 times 1, or 2, so you'll get 5 times 4 divided by 2. Well, 2 cancels into 4, so you'll just end up with simply 5 times 2, which would give you 10. So if you're taking the combination of 5 items 2 at a time, there are 10 possible combinations. Let's say I take the combination of 25 items 0 at a time. So I'm taking the combination of 25 items 0 at a time. So this is going to then be equal to my 25 factorial divided by my 0 factorial times my 25 minus 0 factorial. So that's going to then equal 25 factorial all over 0 factorial times 25 factorial. Well, the good news is the 25 factorials cancel. You just end up with 1 over 0 factorial, which is just going to give you 1 over 1, or simply 1. So if I'm taking the combination of 25 items 0 at a time, there's only one possible combination. And one more problem, then we'll be done. Good one. So I'm going to take the combination of 50 items 6 at a time. So yes, we are taking the combination of 50 items 6 at a time. So that's going to then be my 50 factorial all over 6 factorial times the quantity of 50 minus 6 factorial. Alright, so this would simplify then into 50 factorial all over 6 factorial times 44 factorial. Well, 50 we can reduce some. That'll be the same thing as 50 times 49 times 48 times 47 times 46 times 45 times 44 factorial. What a doozy that one was, huh? Divided by 6 factorial times 44 factorial. Well, the good news is your 44 factorials will cancel. You're now left with 50 times 49 times 48 times 47 times 46 times 45 all over your 6 factorial. Well, what is 6 factorial? That's 6 times 5 times 4 times 3 times 2, and we could really write times 1, but that's not necessary. Okay, let's see what we got here. Well, we know that, so here's the thing. We got to look for what we can cancel. We should only get a whole number. You got to be a bit creative. 4 times 3 times 2 is what? That's 24. Well, okay, so here's the thing. This 4 times 3 times 2 is 24. That'll go into 48 2 times. So that 48 now reduces to a 2. Alright, then we have 6 times 5. And then we have 45. Well, here's the thing also. 5 can go into 45 9 times, so that 45 can get reduced to a 9. Now let's be a bit more creative. So let's see what we got here. Let's go ahead and simplify this a minute. So you'll have 50 times 49 times 47 times 46 times 2 times 9 all over 6. Well, what do you know? Isn't 2 times 9 18? 6 goes into 18 3 times. So both of those combined would just be 3. So what you finally have is 50 times 49 times 47 times 46 times 3. A very big multiplication problem, but that's exactly what you have once you simplify all this. Alright, so 50 times 49 times 47 times 46 times 3. You ready for this? It gives you 15,890,700 possible combinations. So if you take 50 items 6 at a time, you get 15,890,700 possible combinations. And the reason I'm teaching this, particularly the combination section, is going to tie into the next 2 lessons when we get into binomial theorem. The next lesson in particular, we're going to use the binomial theorem, which heavily involves the use of combinations as it's part of the formula to find terms and coefficients when you have a binomial expanded to a power. So we'll do that in the next lesson, and I hope everyone has a great day. Take care.